Hello, this video will help you understand problem number 32 in chapter 7. For some of you, this will be the most difficult problem in the book, or I keep saying in the book, in the chapter. Um, for those of you who realize you can use kinematics, it won't be a problem, but let's see how well you do. You would have a bullet fired at a block. This is my bullet. The block is here. And obviously, once it makes contact, it's going to go over, and the length of the string doesn't change, although if you looked at my drawing it looks like it did. The bullet is now inside the block, and we're trying to find out how far it moves in the X and Y position once the bullet strikes it. So diagram on this one's actually more important than anything else. If you have a good diagram for this, the rest of it really falls into place nicely. So let's make sure you understand what we're doing here. Yes, the center of mass is here, but let's not worry about that. Let's just pretend it's here. It makes it easier to measure it out, and it's the same separation for the block. So I'm going to go over to the left. I'm going to make a triangle there. Okay, I'm going to say that this distance from here to here is h, the height it went, the change in y. Okay, and this is L, that's the value they give you. This is X, the side of the triangle. Well, that means from here to here is simply L minus H. Okay? Now, before we can go on, we have to treat it like a momentum problem. So we have mass of the bullet, I'm just going to call that M1, is 0.028 kilograms. And the mass of the block, so MB, was 3.6 kilograms. But this mass, okay, the combined mass, would have to add the two together. I'm blanking on that. Where is it? Oh yeah, it would be, man, 3.628 kilograms. Alright. Be on the lookout for me making a mistake, because it is getting late. So I'll do my best to catch them, but if I do something that doesn't make sense, I might catch it later. So wait a minute or two in the video and see if I catch it. Hopefully I won't, but we'll find out. So the bullet originally was traveling at a velocity of 230 meters per second. The block was originally at rest, and we need to figure out, well, what is the velocity of the block after the collision? Okay, because if that can be figured out, we can know how fast it was moving when it started swinging, and that will be helpful to figure out how far up it goes and how far it goes in the X direction. Now, to do that, we know we need to find V, but this V that I'm labeling is the velocity the block has right after the collision, after the bullet impacts the block. So the equation would read as M1 V1 initial plus MB VB initial equals MV. We know that whole thing equals 0, so we can simply rewrite it as the velocity here would equal M1 V1 initial all divided by M. So we'd have 0.028 kilograms times a positive 230 meters per second. Sorry, I forgot to show that going to the right will be positive and going up will be positive. All divided by 3.628 kilograms. You should get a velocity that equals positive 1.775 meters per second. You don't want to round that because that's not a value we're looking for as far as the answer goes, just what we need to know to solve. If we can solve for the height, we could easily solve for x, okay, which should be easy to see. If you have this, we already have that, so then we could have this and we could solve for x using Pythagorean theorem. Now, to understand what to do with this velocity, the block is going up. The velocity that's originally horizontally after the bullet it makes contact with the block, okay, and they become one mass. The velocity, although it's horizontal to begin with, is redirected by the string into the vertical direction. So you can actually treat this velocity, the positive 1.775 meters per second, as a vertical velocity that's eventually brought to zero by gravity. So we could use the kinematics equations actually to solve this. The kinematics equation I'm talking about is V final squared equals V initial squared plus 2 times the acceleration, which is going to be g in this case, times what you would see on your equation sheet as delta x, but in this case would just be h. So the final velocity in this case is 0, because it's talking about when things no longer going up anymore. And we need to isolate for the height, so we'd have h equals a negative v initial squared. Keep in mind that negative is multiplied after you square the velocity, and you would need to then divide that by 2g. Okay, so I'm going to zoom out. Probably more than that. So to find h, you would have negative 1.775 meters per second squared, all divided by 2 times 9.8 meters per second squared. Okay, now I'm using g in this case in place of a. So it actually would need to keep the negative sign in that case. I can see that would probably confuse you guys. Let's do this. I'll change g to a so you guys aren't confused by that. But this needs to be a negative number, okay? So originally this equation is v1 squared equals v initial squared plus 2a x final minus x initial. That's the way it looks like on your equation sheet. But the issue is the acceleration is due to gravity, so I was using g, but you're not using the magnitude g, you're using the direction as well. So if you want to write it as a, that's fine. But your height is definitely going to be positive if you said going up was positive. Okay, now, why did it do that? That's weird. Doing that. That's weird. Was I doing something with the button? Okay. Sorry, I don't know. Something's going on with the button on the stylus. So the height you get would be a positive 0.1608 meters. With significant figures, you'd have the height equals a positive 0.16 meters. Now, once you have that height, you can go and use Pythagorean theorem. So in this case, the Pythagorean theorem is going to look like L squared equals x squared plus L minus h squared. If you're going to isolate that for x, you'd have x equals the square root of L squared minus L minus h squared. So you'd have x equals the square root L, which was 2.8 meters squared, minus 2.8 meters minus 1 point, no, sorry, not 1 point, 0.1608 meters squared. So you should get a value of x equals a positive 0.9352 meters. So x equals a positive 0.94 meters when you're dealing with significant figures. So there's your answers for 32. So again, most difficult part is getting the correct diagram. If you've done that, it should be easy to see that you could deal with kinematics to solve for one side. The only thing that's changing the motion of the block is the force of gravity, which is causing the acceleration due to gravity, and you can solve for that using kinematics. Yes, this problem can be solved much easier with energy, but again, you don't know that yet. We will revisit this kind of problem dealing with the energy, and you guys can see how much easier it is. Okay, so that's it for this.